when you're analyzing a dot plot, they look at the shape, they look at the center, and they look at the spread. The shape is just talking about, is this kind of evenly spread out, or is it clustered together somewhere? What could you say about this? Are these pretty evenly spread out, or is there a cluster or a group somewhere in this particular set of data? Is it? Or is it pretty evenly spread out? It's relative. I mean, I know there's more at 31, but I mean, then there's 2, there's 2, there's 2, there's 2, there's 2, there's 1. They're pretty evenly spread out. Okay. What's another word for center? Median. Okay. What's another word for spread? Range. I had somebody in one of my classes ask me, and I don't remember who it was, about range and whether this means that you were supposed to find the two numbers on the outside or whether you were supposed to subtract the 2. Was that you, Marcus? Okay. If it says find the range, they're looking for the outside 2 numbers. Tell me what the range is.
2835.
If it says calculate the range, they want you to do what? Subtract the 2. It's a subtle difference, but if you see the word calculate, they don't want you to just state the numbers. They want you to do addition, subtraction, multiplication, or division. Okay? So, in this, we're going to describe the shape of the dot plot. Are they evenly distributed or grouped on one side? And I would say that they are pretty evenly spread out. Most of them are in the center. There's not many up on the top right, not many on the bottom left, but they're really kind of towards the center. Okay. Now, would your answer and my answer look exactly the same? No. But if you said that these were clustered, I might question that. They're not really clustered together, are they? No. Okay? Describe the center. Because this is a dot plot, how can I find the middle? Taking them off one by one, from the outside to the inside. And I'm going to kind of take them off in groups. There's 3. There's 3. There's 3 more. There's 3 more. There's 3 here. There's 3 here. And if I take 2 more off, where's the center? 31.5. Where did most of them occur? Most, or the mode, was at 31. Would it really matter in terms of what I called the center? 31 or 31.5? That would be a little subjective. Most of the dots occur where? At 31. But the center, where there's an equal number of dots on each side, is actually at 31.5. It says, describe the spread of the dot plot, and are there any outliers? What is an outlier? Okay. Is there, if you take a look at this, is there really an outlier?
No. Yes, 28 and 35.
Are they really outliers? I mean, if it's 29 to 28, is that really way outside the data?
No.
No. 34 to 35, is that? I mean, if this was down here around 10, I would say it's a what? An outlier, but is it really outside of this group?
Yes. No.
Okay. The data values start at 28, they end at 35. Most of them are between 29 and 34, so I'd say 28 and 35 don't look like outliers.
Okay. Turn the page, you're going to see that they've done this part for you. Some example. They've done A, B, and I think C for you. Everybody see it? The page? The page?
107.
Page 170. Okay? This is where they start talking about comparing them. In other words, they've given me two sets of data, and they're asking me to make a comparison. So the first thing we're going to do is we're going to look at softball players versus basketball players, and this goes from what, 4'11" to 5'6". This goes from 5'2" to 6'0". If you visually are comparing the shapes, the softball players, all the data is 5'6" or less, but most of the data in the basketball players are 5'8" and more. If you wanted to compare them, what can you tell me about a basketball player compared to a softball player? They're taller.
People are taller.
Okay? In general, they're taller. Visually compare the centers. The center of the data is about 5'4" here. The center of the data is about 5'8" here. And it means the most common height for softball players is 5'4", and the most common height for the basketball players is
5'8".
there's 4 inches difference between the two. And again, if I look at the spread goes from 4'11" to 5'6". The spread goes from 5'2" to 6'0". There's a greater spread in the basketball players than there is in the softball players. If you go down to where it's your turn, they give you a third set of data. And they ask you to compare your data the same way that they compared the softball to the basketball. So if I take a quick look on the field hockey, which does it best compare to, the softball or the basketball? Definitely the softball players. In fact, 4'9" to 5'6" is the same spread. Okay? What's the basic shape if I compare them? Well, I can find that the dot plots for field hockey and softball players have similar spread. In other words, their shape is somewhat the same. If I actually find the center of the field hockey is actually less than that of the softball player. And again, how would I find the center? Work your way from the outside to the inside. And we already kind of answered this, but the spread for the field hockey and the softball players have similar spreads. By the way, these are textbook answers, not Mr. Huntley answers.
Okay.
I'm going to tell you that there's a couple reasons that I don't even like the way the textbook answered it.
It was too long.
It's not that. It said compare them to what? Softball and what?
Basketball.
Did they make both comparisons? Now, I can see why they compared it to one group because they already made comparisons from softball to basketball. So they made the comparison to the one that was the most similar to. But did they really answer the question the way it was described? No. I mean, if you wanted this to be more accurate, not only would this not be longer, it would be much longer. It would say dot plots for field hockey and softball are similar, but obviously the basketball players would appear to be much taller. The center of field hockey is less than softball, which is also less than basketball. field hockey and softball have similar spreads, but the basketball players has a greater spread. And it really should have that added to that when we're working it out. Everybody good?
Yes. So,
Turn to page 172. This is actually out of the guided practice.
there's only 1 and 3.
Notice they're asking me to compare shapes, centers, spreads, medians, and calculate the what? The range. Okay. What can you tell me about the basic shape of A? Are they evenly spread out or is it in clusters? In fact, it's in 2 clusters. And how about class B? It's one cluster really kind of in the center. There's definitely a big group. You might say that it's evenly spread. Okay. Class A is clustered around 2 areas. Class B is clustered in the middle. How many centers does Class A really have? It really has 2. Although I could find the median, which might be in the middle here, is that median really going to have the same kind of value as finding what the center is of each cluster? No. There's probably not even any data at the true median. So, Class A has 2 peaks between 4 and 13. Class B is centered around what? Around 7. What are the spreads in Class A?
14 to 4.
Yeah, 14 to 4 and 3 to 9. And notice they even commented that this spread had a what? It had a gap in it.
Whoa.
How would I calculate the medians? Outside to inside. And guess what you'd find out? That the median for both of them was at what?
8.
Actually was at 6.
I get that.
The median for both of them ended up being at 6.
What does it mean by, like, for Class A on number 3, no data?
What are we talking about?
On number 3, Class A, it says no data. Like I said.
Oh, it says a gap where there's no data. There's this wide gap in here
Oh.
where there's what?
Oh.
There's no dots. There's no data in between. Okay? When it says calculate the ranges of the dot plots, what are they asking me to do? Subtract. So 14 minus 4 and 9 minus 3. The range for Class A is 10 miles. The range for Class B is 6 miles.